Welcome back to our live training session. We're going to be taking a look in this training module at how to dial in the full throttle operation once again, but this is going to be now engaging VTEC and looking at our high cam tuning. So we're going to learn how to do fuel, spark, and variable cam control tuning in this training module. There's something I want to touch on before we jump in and talk about turning on the VTEC and setting up our tables so that we're ready to do our very first pull here on the mainline dyno to see our power output and do all of that tuning. That's going to be taking a look here under fuel tables, and I haven't mentioned this yet, going and looking here at our map auxiliary compensation. Now, I've zeroed this table out when we were building our base file, and we don't want any map compensation normally when we're doing a true alpha end tune. Now, I have the map pressure sensor wired into the fuel tech, but I do not have it connected to a vacuum source. I did this for a very specific reason. Now, if we take a look, we can see the map pressure here is reading about 0.45. In this case, whether you're using the onboard map pressure sensor, you're not connecting that to a vacuum source, or you're wiring in the factory map sensor, doesn't really matter, whatever situation, you're getting a map pressure reading. In alpha N, you want to make sure this table is initially zeroed out. What we're going to do is use this table for potential compensation if we change elevation with our vehicle. So the intention of this map is to act as a background multiplier or modifier against the main fuel table. Normally it's used to be able to compensate as you get into boost pressure. For example, we can see it's going up here into boost, being able to add additional fuel percentage multiplier so that the main fuel table doesn't have as high of a value in it. But in this case with alpha N, we can use this table as a baro pressure compensation. So if I have elevation change with our vehicle, if we tune it at sea level, for example, and we start to run up to something like 4,000 feet of elevation, we're going to find the engine is going to run rich, and we need to counter-react that. In order to do that, we use a compensation table like this. So because the map pressure effectively is representing our baro pressure, because we don't have the map sensor, whether it's the onboard or the external sensor, measuring engine vacuum, but we're measuring atmospheric pressure, we'd be able to go in at whatever the elevation you're going to be at, whatever the map pressure is reading, we'd be able to go in and use that as a offset for idle, part throttle, and wide open throttle to get your fueling in line. Now, right now, I'm approximately sea level. We see here I'm approximately 0 PSI, so I don't need to populate anything. But if I do change elevation, I'll note what the elevation change is going to be, and I'll watch what my fueling is doing and update the cell points in that particular range or region so that my fueling is back in line with an elevation change. I didn't mention this before, and I probably just thought about it, but I didn't actually go in and talk about it. But I wanted to be very clear with this strategy and what this table can be used for, because you will notice fueling differences and inconsistencies if you're having and driving your vehicle with elevation change in an alpha N tune without some type of a baro compensation. Okay, so now that we've talked about that little bit, let's go in and take a look at turning on our VTEC. The first thing we need to do is lock our VTEC at a low engine speed, so we can then engage it and take a look at figuring out what fueling we need to change in our main fuel table, and then we can also start to take a look at the variable cam tuning, and then at the very end we'll look at spark timing tuning against the very last order of operations. Now, a couple things with this. We should be relatively close with our spark timing. If we jump down in here, we ended up being around 28 degrees of timing. The air temperature was taking about a degree of timing out, so ultimately when we were doing our pulls in that last training module, we were hovering right around 27 degrees of timing. That's definitely relatively high for what I'd expect for this compression ratio for petrol fuel, but we always have to keep an open mind as we're calibrating and tuning our spark timing. Every engine's going to be a little bit different and what it's going to respond to. This is going to be a good starting point, and usually when we engage VTEC, we might be able to bump the timing in just a little bit higher than when we engaged our low cam or non-VTEC spark timing. So spark timing is going to be always a little bit less on low cam, a little bit higher on high cam, usually within a 2-3 degree range. So high cam is usually 2 to 3 degrees higher than low cam. So that's going to be kind of what we expect. But we're going to have a ballpark spark timing here to do our pulls with VTEC engaged. Now, the other thing, if we jump down in here to looking at our other functions, VTEC. This is where we turn our VTEC on. We can see right now the output activation is set here for a yellow wire 12 volt out. We're sending a high side out to turn on the VTEC solenoid. We have the ability to turn on VTEC either under an RPM or over an RPM. Now, over an RPM is the option I'm going to choose here, and I'm going to say turn on over, in this case, 3,000 RPM. Now, this is really lackluster in terms of our VTEC tuning for software configuration. We don't have enough parameters to really be able to characterize things properly. Normally, on other standalone systems, even on the factory ECU, we'll consider throttle position and map pressure in terms of our VTEC activation. We don't want necessarily to have VTEC at 3,000 RPM and part throttle turning on, but we may want to have that at full throttle, having throttle position and map pressure as parameters that we could add if they were available in the software to meet as thresholds would be more ideal. Unfortunately, we're working with what we have in the software at this point in time of filming, and this is all we have. So we're going to say turn VTEC on over 3,000 RPM, and then we can say turn it, well, in this case, it would be turning it off if it drops below 3,000. Now, the other thing that other standalones in the factory ECU has in place is a hysteresis function. That's going to be if we get within this threshold of 3,000 RPM, and let's say we're hovering at 2,990 RPM, and then we go to 3,010 RPM, we're hovering. Let's say the RPM is just hovering back and forth. That's going to turn VTEC on rapidly, so on and off and on and off. That is not ideal. So in this situation, we do not have a hysteresis built in here as well, so you may find yourself hovering in and out of VTEC depending on the conditions that you're operating in. Again, definitely not ideal, but this is all we have to work with for programming. So we're going to go and set our VTEC low at 3,000 RPM, and we're going to jump in here to the variable cam targets, and we're going to go into our last area of the table here and just zero this out. Now I'm going to actually zero it out, let's say here 3,500 and above. We're locking our VTEC at 3,000, so let's say 3,500 RPM above, even 3,000 RPM. We'll go ahead and zero that out. I don't want to have to go in, and the reason why I'm doing this specifically here, if we're engaging our VTEC at 3,000, let's put this back to 30 here, we're going to make sure that the variable cam control is what we normally set up for the low cam, and then we want to zero it out for when the VTEC turns on for high cam. The reason why I don't want to change this where low cam is normally operating is because we've already went into our field table here and dialed our field tables in from between, let's say 0 to 3,000, this range. We've already dialed our field table values in here, so when low cam is on, so we have VTEC off, low cam's engaged, this is going to be correct. Above this RPM here, 3,500 and above, this is going to be where we have to go when VTEC turns on now. This is going to be where we have to probably add a lot more fuel in here. If we take a look at the shape of the table, we can see that the fueling is essentially starting to kind of wind down as engine speed picks up. With VTEC engaged, we're going to be moving a lot more airflow into the engine, and we're likely to need a lot higher fueling values in here. So we'll have to consider that when we're going in and doing our tuning, but that's why I want to make sure the variable cam here is going to be set in this specific fashion. So 3,000 RPM and below, that's going to be low cam, 3,000 RPM and above. We want to start off here and zero everything out.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.